So this question over here is about the limiting reagent. Let's solve this. So before I start with the limiting reagent problem solving, I will introduce you to the concept and it will be a revision for you, of course. What is the limiting reagent? By definition, limiting reagent. How to identify that? What are the qualities of the reagent? Uh, Limiting reagent is the one. One it is one of the reactants, we can say one of the reactant which gets which gets completely consumed completely consumed. And second definition is that limiting reagent limiting reagent will decide the yield of reaction. Means how much of the product will be formed, that will be decided by the limiting reagent. So here I'll give you a simple example. See, if you are preparing a tea, okay, I give this example many times. So here is a one more time I'll give you this example. If I supply you with let's say one cup milk, one cup milk, okay, and 2 kg of tea powder and 4 kg of sugar, okay. If I supply you with this, how much maximum amount of the tea you can prepare, right? Maximum amount of the tea you can prepare is just 1 cup. Why? Because this is in less quantity compared to the other things like tea powder and a sugar. This is in less quantity, right? So just the way because it is supplied, you are not going to use it, right? You are going to use it in that particular ratio only. 1 cup of milk means 1 teaspoon of tea powder and 2 teaspoon of the sugar. That is what the quantity you are going to add to make just 1 cup of milk. If there was ample of water, then you can decide how much of the product you want. But one which is in limiting reagent, that will decide the yield of the product. Like for example, if I'll change this to let's say you are having a 10 liter 10 liter of milk. You are having a 10 liter of milk. Okay, now I'm changing the limiting reagent. And you are having 2 kg of the sugar, but you are just having 2 teaspoon. Okay, 2 teaspoon of sugar. 2 teaspoon of sugar. What is the maximum amount of the tea you can prepare? A good tea, which will taste nicely like a tea. Means it should be a proper um, like it should be proper sweet, right? So here sugar is in very less amount, isn't it? That is just 2 teaspoon. So although milk is in large quantity, this is also in large quantity. You cannot prepare more than 1 cup, isn't it? So here this is the limiting reagent. So standard equation, when we talk about the reaction, standard equation, balanced chemical equation is always like a recipe. Like any recipe, when we say all the ingredients are into a particular ratio, right? So same way we'll write the reaction for this. Mostly these reactions will be given to you, but this simple reaction, if it is a simple reaction like nitrogen reacting with a hydrogen, you should know that. So this is giving you ammonia, right? So this is 2 moles, this is 3 moles. So what does this mean? Understand this carefully. What does this uh sorry, what I did? This is 3. Yeah. So what does this mean is that 1 mole, if this is 1 mole, then N2 is 1 mole, then this should be 3 mole, right? If this is 2 mole, then this should be how much mole it will be reacting? 3 times, that is 6 mole. If this is 3 mole, then it will be reacting how much? 9 mole, right? If this is, I'll write it other way also. If this is 12 mole, how many moles this should be? one third of the 12 because one is one third of 3, right? So one third of 12 is what? 4 mole, right? If this is 16 mole, then or we can take a 15 mole. If this is 15 mole, then how much this should be? 3 mole. Okay, one third of this. If this is 1 mole, if this is 1 mole, then how much this should be? 1 by 3 mole. Okay, if this is 2 mole, then this should be what? 2 by 3 mole. I'm giving all the possible relation. If this is 1.5 mole, then this should be how much? 1.5 divided by 3 mole. Okay. If this is, let's say 7.2 mole, I'm just taking some random value, 7.2 mole, then how much this should be? This should be 3 times of 7.2 moles. That is what you have done. 1 is 3 times of this. This 6 is 2 times, 3 times of 2. 9 is 3 times of 3. 12 is 3 times of 4. These are the relations, like many you can derive. So this is the relation. Now what is the number of moles supplied to you? For that we should calculate the number of moles supplied. Always while solving the limiting reagent concept, given weight, whatever may be the given thing, you should always convert it to what? You should be always converting it to moles. Keep this in mind. Okay, so what is the number of moles of N2? Number of moles of N2. You can use your simple relation how to find a number of moles of N2. That is N, small n, is equal to given weight upon molar mass. What is the weight for the N2 is given? It is 50 gram divided by what is the molar mass for a N2? It is 28, isn't it? So 50 divided by 28. So 50 divided by 28. What you get is 1.78, or I can consider this to be 1.8 mole, right? So this is the thing. So number of moles supplied, I will write over here. Number of moles supplied. How much it is? 1.8 mole of N2. What is the number of moles of H2 supplied? Number of moles of H2 supplied. Number of moles of H2. N is equal to 10 gram, given weight is 10 gram of the hydrogen divided by number of molar mass of hydrogen H2. It is 2, not 2 hydrogens. So this is equal to 5 mole. Now this is what the number of moles supplied. 5 mole of H2. Just understand this thing. Uh, how much will be used? Okay, number of moles used. Number of moles used will be what? If this is 1.85, do this simple calculation. 1.85, 1.8 mole, then how much this should be? It should be 3 times of this. If you are using 1.8 mole of this should be 3 into 1.8, right? But how much it is supplied? Is it supplied in that quantity? 1.8. No, here 1.8 comes to how much? 1.8 comes to 5.4, right? Means if this is 1.8, this should be what? 5.4. It is as good as you are taking like you are saying that uh, 10 liter of milk. If this 10 liter of milk is there, then there should be at least 2 kg of sugar. We can say that, but you are just having two teaspoon, isn't it? So here supplied mole is just 5 mole. You cannot use 5.4 more. So we'll do it opposite. We'll do it opposite. This is not the way, right? Like here you can do just trial and error. You can keep one amount fixed and see that multiplying the particular number, that this is 3 over here, 3 into 1 by 8. In this example it is 3. Is it coming to that, or it should be at least less than what is supplied, right? So this is not used. I'll do it other way. Means if this is 5 mole, I am fixing this. If this is 5 mole, then this should be what? 5 by 3 mole, right? Is it 5 by 3? How much is 5 by 3? 5 divided by 3 is 1.6. Yes, means number of moles used 5 by 3 is 1.6 mole. Understand this. How this 1.6 is coming to me? If this is 5 mole, if you are considering this is to be a 5 mole, out of 1.8 you will be just using uh, 1.6. So number of moles used, that is 5 full number of moles you are using, and here out of 1.8 you can just use 1.6 mole, because number of moles of N2 is one third of 5 mole. That is one third of 5 is 1.6. So what will be number of moles? Number of moles unused. It is what? I'll clean this part because this relation was not correct. You can just make a note of this. I will get some space over here. So number of moles unused will be what? 1.8 was supplied. 1.8 moles was supplied. How much you are using? Just 1.6, which is equal to 0.2. And here 5 was supplied. You are using all 5 moles. So this is 0. Right? So which is the limiting reagent? Identify the limiting reagent. So here hydrogen is the limiting reagent. How do I understand that? Because it is something which is getting completely consumed. Calculate the NH3 form. Calculate the amount of NH3 form. See, from the standard relation, what we can say is that we had said at the beginning that the limiting reagent is the one which will control the yield of the product, right? So here I'm considering this relation. I'm writing 3 mole of H2 gives how much? 2 mole of NH3, right? So 5 mole of H2, 5 mole of H2 will give X mole of NH3, right? So now here I have related 3 to 2 mole. Why not 1 mole to 2 mole? Means 1 mole of N2. Is N2 not participating in a reaction? Why I am not considering 1 mole of N2 giving you 2 mole of ammonia, then 1.6 mole will give you how much? Why I am not doing that? Or 1.8 mole? You can do that, no issue. You can do that. 1.6 will give you how much? You can do that. But here, this is the limiting reagent. That's why I'm relating. That's why I'm relating 5 mole, right? So here, X into, because that is the one who is going to control the yield, no? So X into 3 is equal to 2 into 5. So X is what? 10 by 3 mole. 10 by 3 is what? 3.3 mole of NH3. X is what? X mole of ammonia. That is the number of moles of ammonia formed. Therefore, number of moles of NH3 formed is 3.33 mole. Now, calculate the NH3 form. Like in the case of here in the question, it is not mentioned whether it is a weight or moles. So, amount is just 3.33 moles. What would be the weight of NH3 form? Weight of NH3 formed weight of NH3 form will be 3.33 into 17. 17 is the molar mass of ammonia. It is molar mass of ammonia, or we call this to be a molecular mass of ammonia, right? How much that comes to? Like this is mole. Understand the relation. This is mole, and this is unit is grams per mole. So mole and per mole will get cancelled. What remains is grams per mole. What remains is just grams, right? So how much is this? 3.33 multiplied by 17. So 56.61 gram of NH3 will be formed. So in weight it is 56.61. So this relation what I have written, no, it could be derived from here also. How do we write number of moles? It is given weight upon molar mass or molecular mass or atomic mass, right? So what is given weight? Given weight. So weight will be what? Given weight. This is like a, I'm finding a weight. Given weight we are using, but it is a weight of that particular compound. Actual weight. Weight will be is equal to what? I'll just write weight. This term. Weight will be is equal to N into molar mass. Number of moles into molar mass. Like it is derived from here. Right. That's it. Next is a similar question. Ask on a limiting reagent. Just refer to that. We'll solve this. So question is 3 gram of H2 reacts with 29 gram of O2 to yield water. Means we'll write this reaction H2 reacting with O2 to give you, I'll write it here, H2 reacting with O2 to give you H2O, right? Balance chemical equation would be this. This is a balanced chemical equation. What does this say? If this is 2 mole, if this is 2 mole, this should be 1 mole. If this is 4 mole, this should be what? 2 mole, right? If this is 3 mole or if this is 6 mole, this should be 3 mole, right? If this is 2 mole, or we'll take some other value. If this is something 5 mole, this should be twice of this. I can write it both way. Okay. If this is 1.5 mole, this should be 3 mole, right? So this is the relation between both the species. A number of moles in this ratio, if it is reacting, then you will get 2 moles of a particular amount of water, a particular moles of water, which is a limiting reagent. First step, we need to find what is the number of moles of H2 and O2. So I'll write number of moles supplied. What is the number of moles supplied of H2? Number of moles of H2. For a H2, I am writing for hydrogen. For hydrogen, N is equal to what? Given weight, that is 3 gram divided by 2, which is equal to 1.5 mole. For uh, oxygen, O2 molecule, what is the number of moles? Number of moles is 29 divided by, what is the molar mass of oxygen? Oxygen is 28. 29 divided by 28. 0.99, 1.03. Answer is 1.03. 1.03 means here number of moles of H2 supplied is 1.5 mole and this is 1.03. The thing is very clear. If this is 1.5, how much will be used? Number of moles used. If this is 1.5, this should be half of it, that is 0.75. Yes, half of this is 0.75, isn't it? But if you do opposite, let's say if this is 1.03, 1 minute. I made a mistake. Sorry. Molar mass of oxygen is 32, not 28. Yeah. So this will be just change this. So your number of moles of oxygen will be 0.09. That is 0.09. This is 0.9 mole and this is 1.5 mole. This is what is supplied to you. How much you will be using? If you are using 1.5 mole, then this should be what? 0.75 mole, half of it. But if you are thinking I will be using all the 9 mole, that's zero point 0.9 mole, then how much this should be? 1.8 mole. But 1.8 mole is not supplied. 1 point mole is not, what is supplied is just 1.5. How will you use 1.8 mole? So you cannot decide based on this. You will be deciding based on the hydrogen. Okay, this is a kind of small trial and error. You have to do this over here. So number of moles used, this is 1.5 mole. So this is 0.75 because 0.75 is half of this, as 1 is half of 2. So this is the relation. It is in the same ratio, right? So number of moles unused. So this is 1.5 minus 1.5. Here it is 0 moles, Like here, number of moles unused is 0 mole, means all the quantity of hydrogen is used. Here it is 0.9 minus 0.75. So 0.15 mole is unused. Right? Question asked is which is limiting reagent? Who is getting completely consumed over here? Hydrogen. So H2 is the limiting reagent. Calculate the maximum amount of the H2O that can be formed. Since limiting reagent is H2, what we can say from this is that 2 moles of H2 gives how much? 2 mole of H2O. So obviously the relation is straight, means 1.5 mole of H2 will give how much? X mole. You don't require a cross multiplication. 1.5 will give you obviously 1.5 mole. Therefore, X is equal to what? X is equal to, after cross multiplication, 2x is equal to 2 into 1.5. So X is equal to 2 into 1.5 divided by 2. So what is the number of moles? 1.5 moles of H2O will be formed, right? So number of moles of H2O, number of moles of H2O form is 1.5 mole, right? A weight of H2O form will be what? Weight of H2O form. If it is asked, 1.5 molar mass, or molecular mass of water is 18. So 18 into 1.5, 18 into 1.5, that is 27 gram. 27 gram of H2O. So here answer is 27 gram. Calculate the amount of the one of the reactant which remains unreacted. So what is that? Which is the reactant which is remaining unreacted? O2. Okay, I'll clean this space. I'll go down. So O2 is remaining unreacted. That is how much? 0.15 mole of O2 is remaining unreacted. Unreacted. Now tell me, if that is the case, what is the weight of O2 remaining? Weight, how will convert moles to weight? Weight of O2 unreacted, that is 0.15 into oxygen's molar mass is 32, right? 0.15 multiplied by 32. So 4.8 grams is remaining unreacted. What was the mass of O2 supplied? O2 was supplied 29 gram. And how much is remaining unreacted? 4.8. Out of 29, 4.8 gram is remaining unreacted. Although it was supplied, it is not getting reacted. Same way, like at the beginning, I told you that um, it is excess tea powder and the sugar is not, we will be not using that. It will be just kept in a stock that way. Okay, what is required, only that much will be it. It is similar concept. Hope the concept of the limiting reagent is clear over here. We'll stop this video.